Okay, question 1 from the AIHL exam is here, which is the same as question 2 from the AISL exam, which is here. So the following recording is my answer to the AISL exam question 2. Question 2. A group of 130 applicants applied for admission into either the arts program or the sciences program at a university. The outcomes of their applications are shown in the following table. Okay, find the probability, so part A says, find the probability that a randomly chosen applicant from this group was accepted by the university. Cool. Right, so this is regardless of whether they were accepted to the arts program or the sciences program, just purely that they're accepted to the university. All right, so let's highlight some important information in the question. The only thing really we need to take from here is that we're given the total number of applicants, which is 130. It's somewhat kind that the question has put this in for us. If they hadn't, which they easily could have just left that out, the way we'd find it out is just like adding up all these numbers here. And you'll see if you do that, they'll add up to 130. Right. And so in order to find the probability that a randomly chosen applicant was accepted, what we're going to do is just add up the numbers of the accepted applicants, and we'll divide that by the total number of applicants, which is 130. So let's bring this down. Let's go here. So we'll go here. So the probability someone was accepted is equal to the number of accepted applicants. I'm just going to write that there. Cool. Divided by the total number of applicants. Right, so that blue stuff is just for your understanding. Okay, you wouldn't have to necessarily put that in an exam, but this here would be what you'd probably want to put in an exam. Okay, so the number of accepted applicants, if we go back up here, we've got 17 in the arts program and 25 in the sciences program. So we'll add those two guys up. We get 17 plus 25 all over 130. That is equal to 42 over 130. And we can simplify this down to 21 over 65. Sweet. And I would leave that as my final answer. You are more than welcome to put it in as a decimal if you wish. That would be 0.323 to 3 significant figures, though this fractional answer is exact. It's the exact answer. And so I would tend to suggest leaving it as a fraction is more accurate. So yeah, we'll leave it like that. Cool. Now let's go up and start with part B. An applicant is chosen at random from this group. It is found that they were accepted into the program of their choice. Find the probability that the applicant applied for the arts program. All right, so this is essentially a conditional probability question, though we don't need to bring the formula over or even use the formula because we've got the exact numbers of the applicants for each category, which will make our life a bit easier. So they were accepted, so that's our condition, were accepted, and we've got to find the probability that this accepted applicant applied for the arts program. All right, so we're going to be taking the number of students that were accepted into the arts program, which is 17 here. Let's get rid of our highlighter from last time. Okay, so the 17. We're going to divide that by the total number of students that were, applicants that were accepted. All right, so let's go bring that down here. And in terms of mathy speak, we'd say the arts applied for arts given they were accepted So this is going to be equal to the number of applicants, number of arts applicants that were also accepted, of arts and accepted. Yeah, we'll write it like that. Okay, divided by the total number of accepted applicants, which we'll just take here. All right, nice. And so we'll bring this down here, go into red. Okay, so this is the number of arts applicants that were accepted was 17, all right, and the total number of accepted applicants was 17 plus 25, which we have solved in the last question, but I will write it fully out. So we'll say 17 divided by 17 plus 25, which equals 17 over 42. Now we can't do any simplifying with that, so we'll just leave it like that. And if you wanted to leave it as a decimal answer, you could. 3 significant figures, which would be 0.405. But yeah, I'd recommend just leaving it as a fraction is fine. Okay, well, I've not put a B here. Okay, let's charge on to part C. Okay, so 2 different applicants are chosen at random from the original group. Find the probability that both applicants applied to the arts program. All right, so we got 2 different applicants are chosen, all right, and we've got to find that both applicants applied to the arts program. Okay, so in order to find the probability of the first one we chose, or just one applicant, the probability that one applicant applied to the arts program, what we'd do is we'll take the number of art program applicants, which would be 17 plus 24, and we divide that by our total number of applicants, which was 130. All right, cool. So that will give us the probability of our first one. So let's put that in, and then we'll talk a little bit about the second one. Okay, so we're finding the probability that our first randomly chosen applicant applied to the arts program, and we're going to have to multiply this by the probability that the second randomly chosen applicant also applied to the arts program. So as we said before, we can do our first bit here. So that was going to be 17 plus 24 over 130. Now, in order for us to calculate now the probability that the second applicant also applied for the arts program, and stressing the fact that they're different, we're going to have to remove that first applicant from the pool or from the group. Okay, so they're no longer, we can't choose them again. Okay, so it's basically without replacement. Probability, lots of probability courses talk about that, with and without replacement. So this is without replacement, right? So essentially what we're going to have to do now is subtract 1 from the total number of arts program applicants, and additionally subtract 1 from the total number of applicants. Okay, so if we bring that down here, we're going to have 17 plus 24 minus 1, all right, and then also 130 minus 1. All right, and now if we sort this all out, what do we get? 41 over 130 multiplied by 40 over 129. Now, if we put this into our calculator here, we'll go 41 divided by 130 times by 40 divided by 129. And that would give us this answer here. So we could put that in and round it to 3 significant figures. I know most of your calculators will probably do this for you, but if you wanted to keep with the idea of leaving fractional answers, they are more accurate. They're exact answers. We could just find the product of our numerators, which is going to be 1,640, and divide that by the the product of our denominators, which will be 130 times 129, which gives us 16,770. And now if we divide both of these by 10, we can simplify it down to 164 divided by 1,677. And yeah, there you have it. That is the answer to question 2.